This video is on ordering rational numbers, specifically fractions, decimals, and percentages. So we're going to put the following rational numbers in order from greatest to least. So that's descending order. If I had to put them in order from least to greatest, it would be ascending order. So we're going to do descending. So we have some decimals, some fractions, and a percent. So I find that the easiest way to compare these and put them in order is to change them all to the same form. So I would change them all to decimals. All right, so this one's already a decimal. This one's already a decimal. To change a percent to a decimal, all you have to do is move the decimal point 2 spots to the left. So currently it would be behind it. Move it 2 spots to the left and it's 0.37. And I can put a 0 in front of that, so 0.37. Okay, so changing fractions to decimals is a little more work. Okay, so we're going to do long division. All right, 2 divided by 7. That means that the 7 goes on the outside and the 2 goes underneath. Okay, well 7 can't go into 2, so that's 0. I'm going to add a decimal point because I can add zeros after my decimal. So I'm going to bring my decimal straight up. 7 can go into 20. It goes into it twice. 7 times 2 is 14. So I'm just going to subtract. 20 minus 14 leaves me with 6. I have to add another 0 and bring it down. All right, 7 goes into 60. 8 times. Let's see. Well, I need to keep going out because I have this 0.285. I need to figure out if this one's going to be bigger or smaller. All right, so 7 times 8 leaves me with 56. So I'm going to subtract. 60 minus 56 is 4. Add another 0, bring it down. 7 goes into 40, 5 times. All right, because currently those are exactly the same, I need to keep going out. All right, so 7 times 5 is 35. I'm going to subtract. I get 5. Add another 0, bring it down. All right, 7 going into 50 is 7 times. Okay, I can stop here. I know that I could keep going, but I'm going to stop here because I can now compare it to the other decimals. So I know that this one is 0.2857, and it does keep going. All right, now I have one more to deal with. All right, 3 divided by 8, 3/8. So I'm going to put the 8 on the outside. The 3 goes underneath. 8 can't go into 3, so I'm going to add a decimal point, bring it up to the top, and add a 0. 8 goes into 30, 3 times. 8 times 3 is 24, so I'm going to subtract. Leaves me with 6. To add another 0, bring it down. 8 goes into 60, 7 times. 8 times 7 is 56, so bring that down and subtract. 60 minus 56 leaves me with 4. I need to keep going because I currently have 3, 7, and I have a 3, 7 right there. So add another 0, bring it down. 8 goes into 40, 5 times. Okay, I could keep going. I could write out what 8 times 5 is and subtract, but it looks like I've gone as far as I need to go. So I have 0.375, and it will keep going. All right, so now I need to write these in order from greatest to least, using their original form. So the largest number, all right, so I have 0.375. Think of 0.37, we can add a 0 on the end. 0.370 is smaller than 0.375. So that means that this is our largest number, 3/8. Okay, followed by the 0.370, which was originally 37%. All right, now we have 0.27, 0.2857, 0.285. Remember, we can always add zeros on the end, so you can compare is 0.2850 or 0.2857 bigger. Well, the 7's bigger than the 0, and they're in the same place value, and all the rest are the same. So I know that this one's larger, which is originally 2/7, and you can even cross them off as you go so you can identify which ones you've used. All right, next largest is 0.285, and then our smallest 0.27. And because I have a lot of work there, I'm just going to box my answer. All right, here's one more. Okay, we have 2/5, 0.41, 4.1%. I'm going to change that percent. That's my first thing because it's easy. Take the decimal point, move it 2 spots to the left. There's not a number here, so I just add a 0. Well, we have, this one's a little different, 0.041. And I can always put a 0 in front of that point. So I have 0.041. So it's a little different than the one we did before because we actually had to add a 0 in there. So I'm just going to put an arrow down here so I know what that was. We have 4/9 and 0.44. All right, so let's start with our fractions, changing them to decimals. 2/5. Remember, the number on the bottom goes on the outside, 2 goes underneath, 5 can't go into 2. So add the decimal, bring it up, add a 0 after the decimal point. 5 goes into 20 4 times. 5 times 4 is 20, and so we are done. So 2/5 is 0.4. Okay, so some people can look at that and identify 2/5. Well, that's the same thing as 4/10, which is how you read 0.4. You can do it that way, but when you get to fractions such as 4/9, it's easier to do the long division. All right, so we have 4/9. Put the 9 on the outside, put the 4 underneath. All right, 9 can't go into 4, put the 0, add our decimal points, and add another 0 on. All right, 9 goes into 40 4 times. 9 times 4 is 36. Subtract. 40 minus 36 is 4. Add another 0, bring it down. 9 goes into 40 4 times. 9 times 4 is 36. Subtract. We get 4 again. Do you see what's happening? If we add another 0, bring it down. 9 goes into 40 4 times. 9 times 4 is 36. This is going to keep happening. Okay, so this is just going to keep being 4s. So it's 0.4 repeating. So this one is the same thing as 0.4 repeating. And if that confuses you when you're comparing it to everything else, you can just write out 0.4444 and put the ... meaning it continues. All right, so greatest to least. All right, so we have to find our largest. 0.4 is the same thing as 0.40. I'm just going to write that out for when I compare it to everything else. Okay, well, this one's bigger, 0.41. This one's definitely smaller because it has a 0 in the 10th spot. Okay, 0.4444, looks like this one's bigger compared to the 0.44 though. So comparing these two is kind of tricky. If we add a 0 on the end, we can compare place values. Okay, so they have the same tenths, the same hundredths, but the thousandths, you can see that the 4 in the thousandths is larger than the 0. So that's how we identify this one as larger. So that means 4/9 is our largest. And 0.44 is the next largest. Let's see. Then we have 0.41 is bigger than 0.40 because again, the 4 in the 10th is the same. 1 is bigger than 0 in the 100th spot. Okay, so we have 0.41. Then we have 0. Oh, that was a mistake because I was putting my answer. I was supposed to put 2/5. Okay, so I'm just going to write 2/5. And then lastly, we have a 0 in the 10th spot. So we know that that one's a whole lot smaller than the ones that have the 4s in the 10th spot. So this was originally 4.1%. And that is our answer. Again, box it so that you can tell it apart from the rest of your work. All right, here are 2 problems for you to go ahead and try. Go ahead and pause it here. Come on back for the answers. All right, 3%, 0.03, 1/3. Okay, you can either do long division, or 1/3 is 0.3 repeating, the same thing as 0.333 going on forever. Okay. 0.3 is the same thing as 0.30. I like to, if we have a lot of numbers in the 100th spot, so 2 decimal places out, I like to just add zeros on so it's easier to compare. All right, so it looks like 4/13 is the one that I need to do long division with. Put the 4 underneath at the decimal point, because I know 13 goes into 4 0 times. All right, so then 13 goes into 40 3 times, and 3 times 13 is 39. Subtract, we get 1, add a 0, bring it down. 13 can't go into 10, so it goes in 0 times, meaning we add another 0, bring it down. All right, 13 goes in 100. You can do guess and check and multiply over here. But 13 times 7 gives us 91. Okay, which when we subtract, we get a 9, and I don't really need to go out any further. So I know this is the same thing as 0.307. All right, so our largest. Okay, we have 3s in the 10th spot here. This one has a 0, so I know that's the smallest. So now we have to go out to the hundredths. We have 3s, we have 0s. So these 2 are the biggest. If I add another 0 on, I can see in the thousandths, 3 is bigger than 0. So I know that this is my largest, 1/3. All right, so then my next largest, which I was comparing it to, is 0.33. All right, again, that has a 0 in the 10th spot, so I know it's the smallest. So I'm just going to compare it to these 2 over here. We have 3s in the tenths. They both have 0s in the hundredths. Well, I can just add another 0. Now we have a 7 in the thousandths, a 0 in the hundredths. So, well, 7 is bigger than 0. So that means that 4/13 is our next largest. Then we have, this was originally 0.3. And lastly, our smallest is 3%. So make sure you're comparing where the place values are, because if I just look at the 3, I might say that it's similar to some of the others, like this one, but that 3's in the hundredths, not the tenths, where this one was. All right, and your last one. All right, I'm just going to change 77% to 0.77. All right, 7/9. I'm going to do the long division, 9 on the outside, 7 underneath. I know 9 can't go into 7, but 9 can go into 70 7 times. 9 times 7 is 63. Subtract 70 minus 63 leaves me with 7. Add a 0, bring it down. 9 goes into 70 7 times. 9 times 7 again is 63. Subtract, we get 7 again. Oh, I'm starting to see a pattern. 9 goes into 70 7 times. 9 times 7 is 63. So we're just going to continue getting 7s. So that means that 7/9 is 0.7 repeating, or 0.7777. dot, 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 meaning it keeps going. All right, last one. We have, I'm going to move this over a little so I have a little bit of room because I wrote my 7s kind of large. Okay, we have our 5/7. Okay, 7 goes on the outside, 5 goes underneath. I know 7 can't go into 5, so put my 0 and my decimal points, and I know that 7 can go into 50 7 times. 7 times 7 is 49. Subtract, I get a 1. Add a 0, bring it down. 7 goes into 10 once. Well, I need to keep going because I have a 0.71 here. All right, so 7 times 1 is 7. Subtract, I get 3. Add a 0, bring it down. 7 goes into 30 4 times. 7 times 4 is 28. Subtract. I actually don't need to go any further because I have a 4 there, which it is not similar to any of the other ones. So I know this is 0.714. All right, so I'm going to start looking at, they all start with 0. Then after the decimal, we have a 7, 7, 7, 7, and 7. So now I have to go to the hundredths because all the tenth spots are 7. We have a 7, 7, 0, 1, and 1. So these two are the largest in the hundredths. Okay, I'm going to add a 0 onto the end here because if we looked at the thousandths, this one has a 7, this one has a 0, meaning this one's larger, 7/9. Okay, this was the one we were comparing it to because we knew that was the next largest. We knew these were the two biggest, we just didn't know the order. So I know 77% is next. All right, all three have a 7 in the tenths, but we have a 0, a 1, and a 1 in the hundredths. So these two are the next biggest because the 1 in the hundredths is bigger than the 0 in the hundredths. All right, so we have to look at the thousandths. We have a 4 and we have a 0. If there isn't a number, if it's after the decimal place, just add a 0 onto the end. 4 is bigger than 0 in the hundredths. Sorry, in the thousandths. So that means that 5/7 is the next largest. Then we have 0.71. And lastly, 0.7. All right. Hopefully you were able to get those last two correct, and hopefully you now can order rational numbers, converting everything to a decimal.